This is the video for your notes on SOL 6.4 or fraction operation models. It covers pages 37 through 42 in your notebook. You'll need a pencil and two colors, preferably yellow and pink, to complete your notes. A number that is written with a numerator, part, and a denominator, whole. The line separating the numerator and denominator represents division. So I have 3 that are shaded in, 5 total, and that shows me 3/5, or 3 divided by 5, for a fraction. If I'm repeatedly combining groups of the same size to get the total, I have 1, 2, 3, 4 groups of 3. So if I have 4 groups of 3, I'll get 12, and that is another model for multiplication. If I'm taking a fraction of a given amount, like 2/3, and if I want to take half of those 2/3, I'll only get 1/3, and we can see this by actually multiplying through. So 1 times 2 is 2, and 2 times 3 is 6, and if I simplify that, I get 1/3. So I see that this is another form of multiplication. Repeatedly taking away a group from the total or repeatedly fitting in a group into the total to see how many times you can either take it away or fit the group in. So I see 12 and I'm trying to see how many times a group of 3 will fit into 12, and I see it'll fit in 1, 2, 3, 4 times. Or I have 12 and I'm taking away from that 12 1, 2, 3, 4 times. So the amount that you have is always first. So I have 12, and I'm repeatedly taking away 3, and I can do that 4 times. So 12 divided by 3 would represent this situation. And repeatedly taking away or fitting in is a model for division. Separating a total into a certain number of groups to see how much is in each group. So if I have 12 and I'm separating it into 3 even groups, I have 1, 2, 3 groups, and I have 4 in each of those groups. So I'm separating it into 3 equal groups and I get 4 in each group. This is the separating model for division. This multiplication model is for repeated addition. So 4 times 1/3 means that I'm going to have that 1/3 4 times. So I'm going to draw each of these, separate them into thirds, and I'm going to color in 1/3 for each of those 4 groups. So I have 1, 2, 3, 4 of those thirds colored in. And when I do the multiplication, I see that I have 4 whole groups of 1/3, and 4 times 1 gives me 4, and 1 times 3 gives me 3, and we can see those 4 pieces, or those 4 thirds, that are all together. Now if I wanted to change that to a mixed number, I would just have to kind of move these pieces around. So I would take this piece and move it here. I would take this third and move it as well. And I could see that now this one has 2 more pieces, so that's 1 whole. And this over here is 1/3 of a piece. Don't have any. So 4 thirds is the same thing as 1 and 1/3. And 3 times 1 is 3. 3 plus 1 is 4. So we see that that's true. Here I want 3/4, and I want to see that 5 times. So there's a few different ways you can split it into fourths, but I'm going to split it into 4 boxes, and I see that 5 times. So I'm going to color in 3/4, but I'm going to repeat that 5 times. So I have 3, 6, 9, 12, 15 of those fourths all together. And when I do that multiplication, I see 3/4 times 5 wholes. We get 3 times 5 gives me 15, and it gives me those 15 pieces here. And what are those pieces? We see that they're 15/4. And I can start moving these pieces around to kind of see what that mixed number would end up looking like. So I have one whole box here and one whole box here, one whole box here, 0 here because I took all of those fourths away, and I have 3/4 left over. So I see that there's 3 wholes and 3/4 altogether. So from those 15/4, I was able to make 3 whole boxes and 3/4 of another box. And we get that denominator by doing 4 times 1. Now I want to do 1/2 6 times. So I'm going to split everything in half, and I want that 1/2 6 times. So I see 1/2, 2 halves, 3 halves. I have my 4th half, 5th half, and 6th half. And I could start moving this stuff around, and this piece moved over here would make one whole oval, and this piece moved over here would make another whole oval, and this piece moved over here would make another whole oval. So when I'm looking at this, I see the 1 times 6 gave me the 6 pieces that I see here, and the size of the piece, we get 2 times 1 to give us the half. So I have 6 halves, and I move these pieces around. I have one whole oval here, 0 here, 0 here, because I moved those pieces, one whole here, and 0 here. So I have 3 whole ovals when I move those 6 halves around. And we get a final answer of 3. So here I see 3/5, and I see this fraction of 3/5 repeated 1, 2, 3, 4 times. So 3/5 times 4 whole times being repeated. I see that I have 4 times 3 is 12, and I see 3, 6, 9, 12 of those fifths being shown here, and 1 times 5 gives me 5. So I have 12/5, and if I want to change that to a mixed number, I can move these pieces around and see that these 2 pieces would make one whole, and this piece moved over to this pentagon, and this last fifth moved over to fill that last space in the pentagon. We have one whole pentagon and 0 here because we took all those away, and one whole pentagon here, and I have 2/5 of a pentagon here. So 12/5 is actually equal to 2 and 2/5. We can see that because 5 times 2 is 10, and 10 plus 2 is 12. So that makes sense. This next one, we have 3, 4, 5 out of 9 total. So I see that I have 5/9, and I see that 2, 4, 6 times. So I repeat that 5/9 6 whole times. And 6 times 5 gives me 30. 5, 10, 15, 20, 25, 30 whole pieces, and those pieces are all ninths. So I have 30 of those ninths. When I see what the mixed number would be like, I could start moving these pieces around. So I'm going to start taking pieces here and putting them into the empty spaces in other groups. So I took 2 of those ninths away and put it in the top group, and I can start putting these pieces in any of those empty spaces to try to make boxes whole again. And I can move this one up here, and that one needs one more to be whole, and I have already taken away everything from that bottom left one. So I'm going to take one more away here. I have one whole box filled now in the top left-hand corner, and one box in the bottom right that's completely used up. And I can start moving these pieces around to make one more whole box. And I've got 2 more pieces left that I'll move over to these 2 empty slots. And I need to take 2 more away from this bottom right box to fill the top right box all the way. Now going through, I see that I have pieces that fill that one whole box. I've used up all those pieces. This box is one full box. This is an empty box. This is one full box. And this has 3 out of the 9 pieces left over. So I have 1, 2, 3 holes and 3 ninths. and 3 wholes and 3/9, which could be reduced later. We have 9 times 3 is 27, and 27 plus 3 is 30, so we see that that mixed number is equal to that improper fraction. In this one, we have 2/5 that's colored in, and I see it 1, 2, 3 times. So I see it 3 whole times. 3 times 2 is 6, and 1 times 5 is 5. So I see those 2, 4, 6 fifths all together. I can start moving around these fifths to fill in the empty spaces, and I see that I have 1 whole pentagon, that one's empty, and I have 1/5 left over of that pentagon. So 6/5 is equal to 1 and 1/5 as a mixed number. This next one's a little tricky. We have 2, 4, 5 out of 8. So each of these octagons is showing 5/8. And I see 2, 4, 6, 8, 10. I see 10 whole octagons that have 5/8 of it shaded in. Now, 10 times 5 is 50, and 1 times 8 is 8, and we get that because each of these has 5/8. So I have 5, 10, 15, 20, 25, 30, 35, 40, 45, 50 of those 8s all together. Now I'm going to try to move these pieces around to make whole numbers. So I just keep on taking 8s away from some octagons and moving them into other octagons that I'm trying to fill. So I keep on moving them around and trying to fill each of those octagons with different pieces. So here I see that's 1 whole octagon. I've used up all those pieces. That's 1 whole octagon. That's 1 whole octagon. I've used up all those pieces, so that's 0. Used up these pieces. That's another whole octagon. I have another whole octagon, another whole octagon, and then this one I have 2 out of the 8 pieces left. So I have 1, 2, 3, 4, 5, 6. So I have 6 whole octagons and 2 8s, which could technically be reduced, left over. And 6 times 8 is 48, plus 2 is 50. 4/5 of 1/3, or 1/3 of 4/5. We want to show one of those fractions first, and I see that we have 3 columns and 1, 2, 3, 4, 5 rows. So for this one, we are going to try to take 1/3 of the columns, and I'm going to color in 1/3 of the box. So I'm showing 1/3 with my yellow. And once I'm done with the yellow, I want to take 4/5 of those pieces. So we kind of see that there's 5 pieces in the yellow anyways, and I want 4/5 of that. So I want to take 4 out of those 5 pieces. So I could kind of show 4/5 of the entire box by coloring in 4 out of the 5 rows. So the 4, the numerator here, is showing me that I'm taking 4 out of the 5 rows. Now, the part that's pink and yellow is kind of showing 4/5 of the yellow 1/3, or you could show 1/3 of one of those 3 pink pieces would be 1/3 of the 4/5. So I can also kind of see that the box is 3 by 5 and has 15 total boxes or rectangles in there. And the overlap where the yellow and the pink meet, that is going to be our numerator. So I have 1, 2, 3, 4 out of the 15 boxes that are yellow and pink. So 4/15 would be my final answer. Here I have 3/5 of 4, 5, 6, or 5/6 of 3/5. And on the left side, I see that there's 5 rows, and on the bottom, I see that there are 6 columns. So I'm going to color 5 out of the 6 columns yellow. So the numerator is where the 5 is coming from, and I'm going to color in 5 of those 6 columns, or 5/6 of the entire box, yellow. So out of those 6 columns, I'm going to color in 5 of them. And of those yellow pieces, I want 3/5 of them. So I could show 3/5 of the entire box with pink and coloring in 3 out of those 5 rows. So we can kind of see that there are 5 rows of the yellow, and I want 3 of those 5 rows. So I want the part that's going to be yellow and pink in this picture. And I want to know what part of the entire box, the original box, that covers. So where the yellow and pink overlap, that's going to be my final answer. So 5 times 6 is 30, and we have a 5 by 6 grid, and there's 30 total boxes. And we see that we have 5, 10, 15, or 3 times 5, in the numerator, we have 15 out of those 30 boxes, which could end up being reduced to 1/2. So I see the 3 on this side, and I see the 5 on the bottom here, and 3 times 5 gives me that 15, and the 5 times 6 total gave me the total number of boxes. Now I have 3/4 of 1/2, and it doesn't matter which one you put where, but if I wanted to do 3/4 of the columns, I would need to make 4 columns, and then I would have to color in 3 of those 4 columns. Then I would have to do 1/2 of the rows. So I need to decide which one's going to be the columns and which one's going to be the rows. So I need to show half of the rows. So I'm going to color in half of the entire box pink. And where they overlap, the pink and yellow together would be the fraction of the box or your final answer. So a 4 by 2 grid gives you 8 total. So we have a 4 by 2 grid, and 4 times 2 gives me 8 total boxes. So 2, 4, 6, 8 total boxes. And I have 1, 2, 3, or a 1 by 3 grid. Looking at the numerators, 3 times 1 is 3. That's how we get our numerator. And we get 3/8 of the entire box is yellow and pink. Now, division is how many times a piece can fit into another piece, or how many 3/4 pieces can fit into 2.5 inches. And this is the repeatedly taking away or fitting in model. So how much you have is first, and the second amount is how much you're trying to fit in. So I have the 2.5, and I'm going to mark how much I have, and then I want to see how many times I could fit in a piece that's 3/4 of an inch long, in this case, looking at a ruler. So I have 1, 2, 3 of those fourths, and that's the size of the first box. And we see that this one little piece is 1/4. So I want 3 of those fourths, and then I can make a box. So I have 1, 2, 3 sections will make another box. 1, 2, 3 sections will make another box. And I made 3 whole boxes. I could fit part of another box in. I can only fit 1 out of the 3 pieces that we needed to make that box. So 2.5 divided by 3/4 is 3 1/3, because that's how many times it fits in. So how much I have is 4 3/4. So I go to 4 and count 1, 2, 3 quarters and make that mark. So this is the 4 3/4 mark, and I'm trying to see how many times 1/2 of an inch will fit into those 4 3/4. So I want to see how much it'll fit in. So 1/2 is at this spot. Half of an inch is the same thing as those 2/4. So here I kind of see that I have 2 pieces, and those 2/4 will end up giving me 1/2. So we have 2 more pieces will give me another 1/2 inch box, 2 more pieces for another 1/2 inch box. So we continue doing that, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9 of those boxes that'll fit in. And we have that the 10th box, only part of it fits in. So we want to count up all of the whole boxes that fit in. So we see 1, 2, 3, 4, 5, 6, 7, 8, 9 of those boxes fit in all the way. So we have that 1/2 fits in 9 whole times, and it fits in a little bit more because we see one of those 2 pieces, or half of that box, fits in again. So we see that it fits in 1.5 times. For this next one, we have 3.5. So on here, it looks like 3.5 inches. So we're going to mark the 3.5 inch spot, and that's how much space we have. And we're trying to take 1.25 and see how many times it's going to fit into that 3.5. So I take 1.25 and I see that that's 5 spaces. So I make the same size box, 1, 2, 3, 4, 5. I make another box, and I see that I fit 2 of those 1.25 or 5/4, and I fit 4 out of the 5 sections needed to make that last box. So 4 out of the 5, or 4/5 of that last box, fit in. I have 2 2/3 of this line, so I go to 2 and then I count 1, 2 of those sections and mark the spot that is 2 2/3 on that number line. So I have 2 and then 2 1/3, 2 2/3, and 2 3/3 would be the next one, or 3. And I want to see how many times 1 1/3 will fit in. So I go from 0 to 1 1/3, and I see that I see 1, 2, 3, 4 thirds is the same thing as 1 1/3. So I can make 4/3, and I can fit 1 1/3 in there 2 times. For this next one, I have 3. So I want to show where 3 is on the number line, and the mark for 3 is already there. So I want to see how many times I can fit in 2/3. So I'm going to make a box that's 2/3 of that 1, and it fits with 2 of those thirds. So I count 2/3 out as many times as I can fit in, and I see it fits in 1, 2, 3, 4 whole times. So 4 boxes fit in all the way. And then I see that 1 out of those 2/3 fits in. So I have half of that 2/3 fits in once more. Now we're doing the repeatedly taking away or fitting in model, and it's saying how many 2/3 will fit into 4. So I have 4, and I see 4 hexagons that are shaded in, and I want to try to fit in 2/3. So I'm going to show how many groups of 2/3 I can make fit into those 4 whole hexagons. So first I'm going to look at 1/3 and the second third, and I'm going to highlight that in yellow to show that this is how big the group is. That's how much I'm trying to fit in. And I can fit in one more group and kind of show that with the pink. So I have one group that fit in, second group that fit in. I have a third group of 2/3 that fit in. I had a fourth group of 2/3. I have 1, 2 more thirds that fits in 5 times. 1, 2 more thirds that fits in 6 whole times. So it fits in 6. For this next problem, I want to know how many times 3/5 can fit into 6 holes. So I have 6, and I want to know how many times 3/5 can fit into it. So fitting in is a form of division. So I have 6 whole pentagons, and I am going to take 1/5, 2/5, 3/5, and that's going to make my first group. So I'm going to count 1, 2, 3/5, and that's going to be my second group. And 3 of these pieces is going to make our third group, our fourth group, our fifth group, our sixth group, our seventh group, our eighth group, our ninth group, and our 10th group. So it fits in 10 times evenly. How many 5, 6 fit into 4? So I see 1, 2, 3, 4 shaded hexagons, and I want to see how many times 5, 6 can fit into those 4 shaded hexagons. So I'm going to be dividing 4 into groups of 5, 6. So I see 1, 6, 2, 6, 3, 6, 4, 6, and 5, 6. And I'm going to color all of those in so you can see how big one group is. And that's 5 pieces. So I count at 5 more pieces, and that would be my second group. And I'm just showing how many times I can count those 5, 6 to give me a group. So I see 4 whole groups, and then I see that 4 out of my 5 pieces fit in for that last group that would have been the 5th group. So I have 4 and 4/5, almost 5 times that the 5, 6 fits into the 4 holes. How many 3/4 fit into 5? So I have 5 whole boxes, and I want to know how many times 3/4 can fit into that. So I'm going to divide. So I have 1/4, 2/4, 3/4. I'm going to highlight that so we can see that those 3 boxes would be the size of one group. So that's 1 whole time. So I'm just going to write 1, 2, 3. So I have those 3/4 that I'm going to color in for my second group. And I have third group, a 4th group, a 5th group, a 6th group, and I almost have a 7th, but only 2 out of those 3 pieces that I need actually fit in that shaded area. So I can count 1, 2, 3, 4, 5, 6, almost 7 whole times, but I have 6 whole times and 2/3 of another time that it fits into the shaded area. How many 7/8 fit into 1? So if I'm looking at 1, I want to see how many times 7/8 can fit into it. This is a form of division. So I'm going to count out 1, 2, 3, 4, 5, 6, 7 of those 8s that we see. And that's going to be the first group. So I have one group here, and I have a little bit more shaded area that I need to use. So I'm going to count out 1, 2, 3, 4, 5, 6, 7 more of those 8s. And that would be the second group, but I only have 1 out of those 7 pieces needed to make another group. So I have 1 and 1/7. Don't confuse this with 8ths. We're counting 7 of the 8ths for my one group. This next one, I'm trying to find out how many times 2/5 fit into 3. So I have 3 shaded pentagons, and I'm going to count 2 out of the 5 pieces that are in each pentagon to make one group of 2/5. So I have 1, 2, 3, 4, 5 groups of 2/5, 6 groups of 2/5, 7 groups of 2/5, and I have half of another. And we get this because 1 out of the 2/5 fits in. So don't say that it's 1/5 that we have, it's half of that group of 2/5 that fits in. The first amount is how much you have, and I see that I have 4.5. So step 1 is identifying how much you have in this situation. So 4.5 is what we have to start off with. And step 2, we want to see what am I actually doing. And I'm taking that 4.5 and I am actually separating it into 2 sections or 2 groups. So separate is a division model, so I'm going to separate it into 2 groups. And I'll just write separate here because separating means division. So if I separate it into 2 groups, then I see that the first group is going to get 1/2 of a box, half of a box, half of another box, half of the 4th box, and 1/4 of that last box. So 2 halves together make a whole, and 2 more halves make another whole. So we see 1 whole box here if we put those 2 halves together, and 1 box here if we put those halves together, and I have 2 holes and I have 1/4 left over in the last box. So I'm going to start with how much I have. So I need to identify how much I have, and I have 1, 2, 3.5 in this situation. So 3.5 is how much you start off with. And step 2, I see that I'm separating it into 3 different groups. So separating by 3 means I am going to divide by 3 because separate means to divide in math. And each group, if I separate it into 3 different groups, each group's going to get 1/3 of this box, 1/3 of this box, 1/3 of this box, and 1/6 of this last box. So 3/3, if I put those 3 pieces together, that's going to make 1 whole. So I see that each group will get 1 whole and 1/6. How much I have is 2 1/3. So I'm going to shade in 2 1/3. So I'm going to color in 1, 2 1/3 of this last box. So that's how much I have, and I want to separate, because I want to divide, I want to separate that 2 1/3 into 2 groups. So let me color in the 2 1/3 that I had to start off with, and I'm going to separate each of those pieces into 2 groups. So if I separate this into 2 groups and I take this much, each group will get 1/2 of that hexagon. Each group will get 1/2 of this hexagon, and each group will get half of that little piece. Well, that little piece is actually a 1/6. So each group will get 1/6 because 2/6 would be equal to that 1/3. So 1/2 and 1/2 equals 1 whole, and 1/6 in each group. So if I have 3 3/4, then I'm going to color in 3 of those octagons, and I'm going to split the last one into quarters, and I am only going to color in 3 of those quarters. And for step 2, I am going to separate that 3 3/4 into 2 groups. So if I color in the same amount as before, then I'm going to separate it into 2 groups. I am going to give 1/2 of this octagon to each group. I have 1 whole octagon, which means I'm going to give half of the octagon to each group. I'm going to give half of this 3rd octagon to each group. And I'm going to split each of these little pieces into 2 groups as well. And I see that I just made 8 total pieces. So these are 8s. And I'm going to give 1 of each of those 3 pieces. So I'm going to give 3 of those 8s to each group. So I have 1/2 and 1/2 gives me 1 whole, but I have this 1/2, which is the same thing as 4 8s. If we look on the side, 1/2 is equal to 4 8s, but I'm going to add the 3 8s and get 7 8s. So this 1/2 is 4 8s, and I have 4, 5, 6, 7 8s in the end.